In triangle ABC, altitude AD and BE are drawn to the corresponding bases. If angle BAC is 45 and angle ABC is theta, then AD by BE equals. So, ABC angle ABC is theta, angle BAC is 45. AD and BE are drawn to the corresponding bases. AD is the base, is the perpendicular to this. BE is the perpendicular to this. We need to find AD by BE. Ratio of the altitudes. Area can be written as half into base into height. Ratio of altitudes will be opposite of ratio of bases. So we can simplify to that and then something else will open up. So area of this triangle is half into BC into AD. This is also equal to half into AC into BE. These two should be equal. So both are area. So half and half gets knocked off. BC into AD equals AC into BE. We want to find AD by BE. This goes here. It should be equal to AC by BC. We want to find AC by BC. Nice. Now AC by BC. We know A by sin A equals B by sin B equals C by sin C. So we know AC by sin theta, so angle opposite equals BC by sin 45, angle opposite. BC by sin of ABC. We want to find AC by BC. AC by BC equals sin theta by sin 45, sin theta by 1 by root 2 sin theta, if that's there. A half into base into height is half into base into height. So we know we want to find ratio of height. It's the opposite of ratio of bases. Once we know we need to find ratio of bases. A by sin A equals B by sin B. We need finding ratio of sine of the two angles. One angle is theta and the angle is 45, sin theta by sin 45, which is root 2 sin theta. Working along the times taken by Anu, Tanu and Manu to complete any job are in the ratio of 5:8:10. They accept a job which they can finish in 4 days if they all work together for 8 hours per day. That is 4 into 8, 32 hours. And remember, this is the ratio of the times taken. So Anu, Tanu, Manu, time taken, ratio 5:8:10, or their efficiency or extent to which they do, not even going to write efficiency, tasks per day or task per unit time. This is 1 by 5 is to 1 by 8 is to 1 by 10. Very simple funda. If you take 5 days to finish a task, in 1 day you can finish 1/5 of the task. If you take 8 days to finish a task, in 1 day you can finish 1/8 of the task. If you take 10 days to finish a task, in 1 day you can finish 1/10 of the task. So if you take 5 days, 8 days, 10 days, then in 1 day you finish 1/5, 1/8, 1/10. This is what you get done in 1 day, 1 unit of time. Lovely. So 1 by 5 is to 1 by 8 is to 1 by 10. LCM of 5 and 8 is 40. It's a multiple of 10 also. So multiply by 40. I'm going to take this ratio and multiply by 40. Why am I doing that? I really like dealing with integers, not with this 1 by 5 business. 1 by 5 into 40 is 8. 1 by 8 into 40 is 5. 1 by 10 is 40. This is the ratio of the rates at which they work. Or Anu does 8x units of work. Tanu does 5x units of work. Manu does 4x units of work in per time for 1 hour or 2 hours or 3 hours or whatever that measure of time. And then how long do they work for? They accept a job which they can finish in 4 days. They all work together for 8 hours per day. That means if I think of it as 8x, 5x, 4x, all three put together, 32 hours, they can finish the task. 8x plus 5x is 13x plus 4x is 17x. 17x into 32 is a total task. That's a task ahead of them. However, Anu and Tanu work together for the first 6 days, working 6 hours 40 minutes per day. Anu and Tanu, these two only, that is 8x plus 5x, this is 13x. They work 6 hours and 40 minutes per day for 6 days, or number of hours is 6 into 6, 2 by 3. 40 minutes is 40 by 60, 2/3 of an hour. 6 hours to 6, 2 by 3 hours. This is 20 by 3, 6 into 20 by 3. which is 40 hours. So what they do is 13x into 40. I'm guessing this is less than that. Otherwise, they would have finished the entire task before that. What is the question then? Then the number of hours that Manu will take to complete the remaining job working alone was nice, simple. So the 17x into 32 is the size of the task. 13x into 40 gets done by these two in 6 days, working 6 hours, 40 minutes per day. You find the difference. This is what Manu completes. So 17x into 32, 17 2s are 34, 4, 3, 51 plus 3, 54. 13 into 40 is 520. This is 544x, 520x. 24x is what Manu does. What can Manu do? Manu does 4x in 1 hour. 24x, he'll take 6 hours. 4x into 6 is 24x is 4x into 6. 4x units per hour, 6 hours on work. Lovely question, but very time consuming question. You have to go from time to rate, get the ratios, define the total task, find out what has been completed, get to the remaining, again get to the number of hours Manu works. Regular polygons A and B have sides in the ratio 1:2. Interior angles in the ratio 3:4. This is A. This is B. Let's say A has n sides. B will have 2 end sides. Sum of interior angles of a polygon of n sides is 180 times n minus 2. So the average interior angle, each interior angle, the value of each interior angle is in the ratio 3:4. Sum of all interior angles divided by n will be each interior angle. Why? Because we're dealing with a regular polygon. A regular polygon is one where all sides are equal, all angles are equal. So each internal angle here is 180 into n minus 2 by n. Each interior angle here is 180 into 2n minus 2 by 2n. This is the total sum of all interior angles, divide by 2n, that will be each internal angle. This is the sum of all internal angles, divide by n, that will be each internal angle. This ratio is 3:4, or cancel off the 180, cancel off the n. This 2 goes there, 2 into n minus 2, or we can cancel even the 2, it becomes n minus 1. N minus 2 is to n minus 1 is 3:4. You have to cross multiply and simplify. 4n minus 8 is 3n minus 3. N is minus 3 plus 8, which is 5. Or the polygon A is a 5-sided polygon, which is a pentagon. Polygon B is a 10-sided polygon, which is a decagon. Then the number of sides of B equals 10. Very mechanical question, very simple question. You have to look at it and knock it off. A beautiful question. If A and B are non-negative real numbers such that A plus 2B is 6, then the average of the maximum and minimum possible values of A plus B is. We know that A plus 2B is 6. We want to find the maximum and minimum possible values of A plus B. Seems like a tricky question, but that's actually a freebie. Right? They are non-negative real numbers. This A plus 2B, I want to break this as A plus B plus B. That's it, done, we're through. We want to find maximum and minimum values of this. This is maximum, that should be minimum. This is minimum, that should be maximum. What is the minimum value B can take? Non-negative, minimum value B can take? 0. Non-negative, it can't go below 0. What is the maximum value B can take? B is maximum, A should be minimum. Put A as 0 because A cannot be less than 0. Put A as 0, B is 3. Done, we are through. If B is 0, then A plus B is 6. If B is 3, A plus B is 3. 6 minus 0 is 6, 6 minus 3 is 3. Or A plus B maximum value is 6, A plus B minimum value is 3. We want to find the average of the maximum and minimum possible values of A plus B. Average of 6 and 3, 6 plus 3, 9 by 2, 4.5. Done. Thinking about A plus B is tricky. Thinking about B is super simple. This is minimum, this is maximum, this is maximum, this is minimum. Done. Through. Manu earns 4,000 per month and wants to save an average of 550 per month in a year. In the first 9 months, his monthly expense was 3,500. And he foresees that 10th month onwards, his monthly expense will increase to 3,700. In order to meet his yearly savings target, his monthly earnings in rupees from the 10th month onward should be. Nice. For the first 9 months, he saves 500 bucks. And I'm going to break this as 9 months, and 3 months. 4,000 minus 3,500 happens for 9 months, or he saves 500 into 9. He wants 550 into 12. I'm going to break it as 550 into 9, 550 into 3. I can do this very algebraically with a big equation, but I'm going to do it more intuitively. Or he falls short by 50 bucks in each month. Or total deficit is 450. 50 into 9. He wants to make this up there. 50 into 9, 450. This is delta. He has 3 months to make it happen, or each month he can make up 150. We're talking about averages. 150, 150, 150 is true. He anyway wants to say 550. He needs to make 150 more than that, or he has to do 700 into 3. This 700 is 550 plus 150. Where does that 150 come from? 450. His deficit is 450. He has to make that up in the last 3 months. 3 months, 150, 150, 150. Each month 150, that will come. Or he needs to save 700 rupees per month in the last 3 months. His monthly expense will go to 3,700. His income should be 3,700 plus 700, which is 4,400. Again, a freebie question should be setting it up and knocking it out. The two containers of the same volume. First container half filled with sugar syrup, and the second container half filled with milk. Half the content of the first container is transferred to the second container. Then half of this mixture is transferred back to the first container. Then half the content of the first container is transferred back to the second container. We stop there, luckily. Then the ratio of sugar syrup and milk in the second container is two containers, the same volume, half filled with sugar syrup and half filled with milk. Container 1, container 2. Let's say X of sugar syrup, X of milk. Then what do? We transition from here to here. When we do that, at step 2, this will become sugar and milk. Sugar will become X by 2, no milk. Sugar is to milk. Sugar will become X by 2, milk continues to be X. And then we shift from here to here. So what will get added? This is first shift is done. Second shift, when we do this, half of X by 2 will get added here, X by 4. Half of X will come here, X by 2. Then get this and shift there. I'm doing this straight away. I notice that I'm going to deal with X by 2, and then X by 4, maybe X by 8, one more step. I'm thinking about this and saying, look, I'm dealing with this 1 by 2 business. I'm going to simplify this. Say all remain the same. Container 1, container 2. This has sugar to start with of say 8x. Milk to start with of 8x. Half of this goes here. So step 1, step 2, step 3. I'm going to track sugar is to milk, sugar is to milk. After the first transfer is made, this becomes 4x and 0. This becomes 4x and 8x. Step 2, sugar and milk. From 4x and 8x, half and half come here. Same ratio it will come back to. 4x by 2 is 2x. Sugar will become 4x plus 2x, 6x. Milk will become 8x by 2, 4x. Here, what will be remaining, sugar is to milk, will be 2x and 4x. Adding up to 10x, adding up to 6x, total 16x. That's what we start with. One round of check, all good. Now what do? We send from here to there. 6x will become 3x, 4x will become 2x. Sugar to milk, 2x plus 3x is 5x, 4x plus 2x, 4x plus difference 2x is 6x. This is 11, this is 5, adding up to 16, that also seems to work. Step 1, step 2, step 3. Ratio of sugar to milk in the second container at the end of this 5:6. Done. Not too difficult. We have to do it methodically. It really helps. We take the first two numbers to be 8x and 8x and not x and x. On day 1, there are 100 particles in a laboratory experiment. On day n, where n is greater than or equal to 2, 1 out of every n particles produces another particle. The total number of particles in the lab experiment increases to 1000 on day 1. Then day m, then m equals. Nice. This day 1, day 2, day 3, day 4, day m. And day 1 there are 100. What are the additions that happen? On day 2, 1 out of every 2 particles produces another particle. So on day 2, 100 to start with, half of 100 gets added. Half into 100. 50 get added. We'll have 150. Nice. What happens on day 3? We have 1 by 3, 1 by n. When n is 3, 1/3 of particles get added. What gets added? 1 by 3 into 150, which is 50. This becomes 200. Day 4, what gets added? 1 by 4th of 200, which is 50. This becomes 250. 1 by 5 of 250, 300. 1/6 of 300, 350, and so on. Or, quite simply, every day 50 particles get added. We start with 100. Somewhere down the line, we're going to hit 1000. 50, 50, 50, we keep adding every day. We have to add 900, or we add for 18 days. Number of times we add is 900 by 50. 50 added each day. 900 is 1000 minus 100. We started with 100, we need to add 900. 900 by 50 is 18. 18 times we add. On day 1 we have 100. Day 2 we add 50. Day 3 we add 50. 18 days we add. Our total number of days is 19. Very nice, juicy question. This description part is tricky, but otherwise the question is very simple. A lot of these questions put D1, D2, D3, D4, track, see, visualize, then we can simplify. The average of a non-decreasing sequence of n numbers, A1, A2, A3 till An is 300. If A1 is replaced by 6A1, the new average becomes 400. And the number of possible values of A1 is a nice, beautiful question. A non-decreasing sequence. What does it mean? It means A1 is less than or equal to A2, less than or equal to A3, less than or equal to A4, all the way till An. Something to keep in mind. We know that A1 plus A2 till An divided by n is 300. A1 is replaced by 6A1. 6A1 plus A2 till An divided by n, average will be higher, average is 400. Nice, excellent. Or A1 plus A2 till An is 300n. We'll rewrite it like this. Remove this. Say, hey, this is 300 times n. Say, this is 400n. Or if we subtract one from the other, we have 5a1 equals 100n, or a1 is 20 times n. Nice, brilliant. Now is where this question gets interesting. This part kicks in. A1 is 20n. A2 should be greater than or equal to 20n. A3 should be greater than or equal to 20n. Each of these entities is at least 20n. The smallest they can be is 20n. Right? And we know A1 plus A2, A3 till An is equal to 300n. Each of them is at least 20. Should be adding up to 300. We put all of them as 20. It's a minimum possible scenario. In that situation, adding up to 300, let's find what value n can take. Or we say 20n into n, all of them are equal, we get to 300n, or n is 30 by 250. If n were 15, then each of the quantities could be 20n, and adding all of them up, we'll get 300n. Brilliant. That means if n were 16, a1 being 20n, get even 20, 20, 20, 20, 16, 20n. It's an extreme scenario. If you still add up to 320n, that's not possible. The maximum value n can take is 15. So n is a maximum value n can take. N is 15, we can find a1. a1 is 15 into n. We can find that. Can n be 14? Yeah, n can be 14. a1 would be 280. 14 into 20, 280. Adding the first 14 terms would be, average would be 300. Sum would be 300 into 14. We can find different combinations, it will work. N can be 14, 13, 12, all the way till 3, 2, 1. Just want to check the extreme condition n equal to 1. If n were 1, there's only one term, then a1 is 300. 6a1 equal to 400. This is not possible. This doesn't work. So n cannot be 1. But everything else will work. N equal to 2. a1 plus a2 is 600. a1 is 2 into 15, which is 30. a2 can be the remaining. This will work. Nothing wrong. So this can work. So a1 plus a2 being 600, n equal to 2 will work. From 15 all the way till 2 will work. 14 different values. N equal to 1 will not work. That doesn't work. So 14 different values. Absolutely beautiful question. Brilliant question. Let R and C be real numbers. If R and minus R are roots of 5x cubed plus cx square minus 10x plus 9 equal to 0, then C equals. Nice question. 5x cubed plus cx square minus 10x plus 9 equal to 0. Then the roots are R and minus R. Let the third root, with 3 roots, a cubic equation, the third root be P. Sum of the roots will be R plus minus R plus P equals minus C by 5. Minus of this by 5. Product of the roots taken 2 at a time, which is R into minus R plus RP minus RP equals minus 10 by 5 minus 2. Product of the roots R into minus R into P equals minus plus minus 9 by 5. Using these 3 equations, we should be able to find a value for C. Sum of the roots taken 2 at a time, 3 at a time. So R plus minus R is 0, P is minus C by 5. RP minus RP is 0, minus R square equals minus 2, R square equals 2, R is root 2. Here we have minus R square into P equals minus 9 by 5. Cancel off the minus, R square is 2, 2P equals 9 by 5, P is 9 by 10. We know P is minus C by 5, 9 by 10 equals minus C by 5, or C equals minus 9 by 2. Nothing, no rocket science here. To manage the equations, manage some algebra, be comfortable with R minus R and P, sum of the roots, product of the roots taken sum of the roots taken multiplying 2 at a time, 3 at a time. Be careful with minuses and pluses, then we are through. Suppose for all integers x, there are two functions f and g such that f of x plus f of x minus 1 equal to 0 and g of x equal to x square. If f of x square minus x equal to 5, the value of f of g of y plus g of f of 5 is. Tough question. Let's simplify this. All integers x. So f of x plus f of x minus 1 equal to 1. That's what this is. G of x equal to x square, that is very easy. Nice. So I'm going to write a few equations. F of 2 plus f of 1 equals 1. F of 3 plus f of 2 equal to 1. F of 4 plus f of 3 equal to 1. And so on. F of 2 plus f of 1 is f of 3 plus f of 2. Both of them have f of 2. Both are equal to 1, or f of 1 should be equal to f of 3. Both of these have f of 3, f of 2 should be equal to f of 4. Beautiful. F of 2 plus f of 1 is nothing but f of 2 plus f of 3. Both are 1. This plus this equals this plus this. F of 2 is common, or f of 1 is equal to f of 3. Between these two, f of 3 is common, f of 2 is equal to f of 4. Or we just extrapolate it beautifully. We'll get a wonderful equation, which is f of 1 equal to f of 3 equal to f of 5 equal to f of 7 equal to f of 9, and so on. Exactly same approach. We have f of 2 equal to f of 4 equal to f of 6 equal to f of 8 and so on. All even numbers, f of that will be same. All odd numbers, f of that will be same. Nice. We have f of x square minus x equal to 5. What am I going to do? I'm going to put x equal to 1. F of 1 square minus 1 equal to 5. F of 0 is 5. F of 2 square minus 2 is equal to 5. F of 2 is 5. 3 square minus 3 is f of 6, that is 5, or all even numbers. F of all even numbers is 5. So one part of the equation we have got all of these fellows are equal to 5. Nice. Now let's say this. F of 2 plus f of 1 is 1. F of 2 plus f of 1 is 1. This is 5. 5 plus f of 1 is 1. Or f of 1 is minus 4. Or we have a brilliant equation. F of even integer is 5. F of odd integer is minus 4. Brilliant. Now what do we need to find? We know g of x equal to x square. That is nice and comfortable. We want to find f of g of 5 and g of f of 5. F of g of 5 is f of 25. We want to find f of 25 plus g of f of 5. F of 25 is an even number. 25 is an odd number. F of 25 is minus 4. G of f of 5. F of 5 is an odd number. F of 5 is an odd number. So f of 5 will be minus 4. It is g of minus 4, which is minus 4 whole square. So it is minus 4 plus 16, which is 12. F of 25 is minus 4, f of 5 is also minus 4, both odd numbers. And so we know f of 25 is minus 4. G of f of 5 is g of minus 4, which is x square, minus 4 the whole square, 16, minus 4 plus 16. Beautiful question, delightful question. Not heavy duty function theory algebraically, but tons of common sense and very comfortable with putting numbers and playing with them and writing equations. That basic comfort level with writing this and then drawing this link and then saying, hey, all odd numbers are same, all even numbers are same. That is super important. In an election, there were 4 candidates and 80% of the registered voters cast their votes, not casted their votes. One of the candidates received 30% of the cast votes, while the other 3 candidates received the remaining cast votes in the proportion 1:2:3. The winner of the election received 2512 votes, more than the candidate with the second highest, and the number of registered voters was. Registered voters, so some number of registered voters are there. So this is T. 80% of them cast their votes. CAST, not talking about CASTE, although in election context that seems like, hey, that's something people talk about. Right? We're talking about cast votes, not cast votes. So one of the candidates received 30% of the cast votes. So we call this as X. One guy gets 30% of X, while the other 3 candidates received the remaining cast votes in the proportion 1:2:3. So remaining is 70% of X. That gets broken in the ratio 1:2:3. So this 30% goes to one candidate, 70% goes in the ratio 1:2:3, or that these 3 candidates will get 70/6%, 70 into 2/6, 70 into 3/6. These 3 fellows. 1 plus 2 plus 3 is 6 units. Break 70% into 6 parts. 1 part, 2 part, 3 parts. 3 out of 6 is half. 2 out of 6 is 1/3. 1 out of 6 is 1/6. So this guy gets 70% by 6. This guy gets 70 into 2/3. This guy gets 70 into half. This is 35%. I'm very interested in this. Why? Because then that means this guy has won the election. This guy has already got 30. That guy has got more than 30. 35%. This is going to be less than 30%. That I know. 70% by 3. This is half of that. Much lesser. Or the guy who won the election won 35% of the total cast votes. and the guy who came second won 30% of the total cast votes. Or the difference between these two is 2512. 5% of X is 2512. It's true. X is the total votes cast. 5% is 1 by 20, or X is 2512 into 20. We want the total number of registered voters. Registered voters is 80% of the registered voters is X, or 4 by 5 of total registered voters is 2512 into 20, or total number of voters is 2512 into 20 into 5 by 4. 20 into 5 is 100, easy to multiply. Do 2512 by 4 into 100. 2512 by 4, 2512 divided by 4. 6, 11 makes it 232. 628 into 100. 62800 is the number we're looking for. Methodically go for it, nice and simple, crack it. Next one. The number of integers greater than 2000 that can be formed with the digit 0, 1, 2, 3, 4, 5, using each digit at most once. At most once, that means no repetition. So maximum we can form 1, 2, 3, 4, 5, 6 digit numbers. Using these 6 digits, we want to find all integers greater than 2000. 2000 is a 4-digit number. We are basically counting all 5-digit numbers, all 6-digit numbers, and then some 4-digit numbers. We want to think about 5 digits. Then we'll think about 6 digits. Then we'll move on to 4 digits. 1, 2, 3, 4, 5. This digit can be 1, 2, 3, 4, 5. This cannot be 0. The starting digit cannot be 0. Right? Let's say this is A. This one, it can be 0, but it cannot be A. Why? Because each digit is used at most once. It cannot repeat. On this B, this digit 0 to 5, except A and B. Or there are 5 options for this. Out of 6 we subtract A, 5 options for this. Out of 6 we subtract A and B, 4 options for this. Here what will we do? We'll say 0 to 5 minus of A, B and C. Out of 6 options we subtract 3. 5 into 5 into 4 into 3 into 2. Not many 5-digit numbers are possible. Let's move to 6-digit numbers. A, B, C, D, E, F. Nice. A has again 5 options. 1, 2, 3, 4, 5. B would be 0 to 5 minus A. 5 options. 0 to 5 minus A and B, 4 options. 3 options. 2 options. 1 option. It will be 5 into 5 into 4 into 3 into 2 into 1. This is 5 into 5 into 4 into 3 into 2. Both are same. There's an additional 1 there. That's it. 5 into 5, 25. 25 into 4, 100. 100 into 6, 600. 5 into 5, 25 into 4, 100 into 6, 600. 600 5-digit numbers, 600 6-digit numbers. Now let's move to 4-digit numbers. Looking at 4-digit numbers more than 2000. The first digit cannot be 1. It can only be 2, 3, 4, 5. Very interestingly, if the first digit were 2, all possible numbers are more than 2000. So you don't have to worry about first digit being 2 and not counting a few numbers. All numbers with first digit 2 will count. Right? So A, there are 4 options. B, 0 to 5, except A, 5 options. 4 options here, 5 options here. C will be 0 to 5 minus A comma B. 3 options here. 4 into 5 into 4 into 3. 4 into 5, 20. 20 into 4, 80. 80 into 3, 240. So we had 5-digit numbers and 6-digit numbers, 600 and 600 each. 4-digit number, 240. 1200, 1400, 1440. Hopefully that's there in our choices. Yes, it is. Done. For some natural number n, assume that 15,000 factorial is divisible by n factorial factorial. largest possible value of n is 1. So 15,000 factorial. Is it divisible by 5 factorial? Factorial. 5 factorial is 120 divided by 120 factorial. This works. 5 works. Put a 6 factorial. That means 120 into 6. 720 factorial. This is 15,000 factorial. 1 into 2 into 3 into 4. All the way till 15,000. 1 into 2 into 3 into 4 are 720. 6 is also possible. Put 7 factorial. 720 into 7. 0, 4, 1, 5040. Yep. That also sits within this. 7 should be possible. Put 8 factorial. 5040 into 8. 0, 32. 40,320. 8 factorial will become bigger than 15,000 factorial. So 8 is not possible. 7 is possible. It seems like a very intimidating question. I got shocked when I read this question. N factorial. That we're dealing with very large numbers. We have to figure out something. He's basically saying find the smallest n such that n factorial is greater than 15,000. Our answer is 1 less than that. 8 factorial is more than 15,000. 7 factorial is less than 15,000. Sorry, 7 factorial is less than 15,000. 8 factorial is more than 15,000. That's all we need to find out. We're through. And so once we decide to say, okay, let me poke this, I'm not going to get intimidated by this, then this becomes a very easy question. The number of distinct integer values of n satisfying this is, and so this by this should be less than 0. Right? That means you could have a scenario where it is positive by negative or negative by positive. Nice. So what am I going to do? I'm going to think about when does this become positive and negative? When does this become positive and negative? I'm going to solve for 4 minus log n to the base 2 greater than 0. Okay. Or log n to the base 2 is less than 4. 2 power 4 is 16, n less than 16. N is less than 16, this is positive. N is equal to 16, this is 0. N greater than 16, this is negative. Same funda, this one. 3 minus log n to the base 4 greater than 0. Log n to the base 4 is less than 3. N less than 4 cube, 64. And so, if n is less than 16, this is positive. If n is less than 64, this is positive. So, I'm going to break our world into 3 parts. Less than 16, 16 to 64, greater than 64. Nice. Less than 16, this is positive by positive. Greater than 64 will be negative by negative. This is negative, this is definitely negative. What happens at 16? At 16, this goes to 0. What happens at 64? At 64, this goes to infinity or undefined. So, it is less than 0. So, I'm worrying about 16 to 64. In this case, the denominator is positive, numerator is negative. This is the range we are looking for. 64 to 16, but without counting 16, without counting 64. Or 17, 18, 19, 20, 21, all the way till 63. The first 63 natural numbers, subtract the first 16, 47. 17 to 63, all the numbers included. 17, 18, 19, 20, 21, all the way till 63. Break it down to the 3 regions. Think about negative by positive, positive by negative. Here it is both positive, here it is both negative. In between it works for us. That's the first step. Then be careful about, hey, am I counting 16? Am I counting 64? Is it less than 0 or less than or equal to 0? I'll be a little careful with doing the math. Then you're through. All numbers from 16 to 64 or between 16 and 64 without counting 16, without counting 64. It was a beautiful question, super challenging. In an examination, there were 75 questions. 3 marks were awarded for each correct answer, plus 3 for correct answer. 1 mark was deducted for each wrong answer. and 1 mark was awarded for each unattempted question, not attempted. Right? Plus 3 minus 1 plus 1. Right? Ryan scored a total of 97 marks in the examination. The number of unattempted questions was greater than the number of attempted questions. This, let's say x, y, z. Z is greater than x plus y. All three put together is 75, or z is more than half of it. 38 or more, 37 or less. X plus y could be 37, z could be 38, 38 or more, 37 or fewer. At least 38 questions were unattempted. And that's what we know. Then the maximum number of correct answers that Ryan could have given in the examination total is 97, getting 97 marks totally. So we can say 3x minus y plus z equals 97. We know x plus y plus z is 75. We know z is greater than or equal to 38. So this is where we stand. And so there's a beautiful way of kind of tackling this, simplifying this. This is a plus 3 minus 1 plus 1. Generally in our world, unattempted questions are given no marks. So we say 75 totally. Every question you get some mark. That's a given. So I'm going to remove that from the equation completely. I'm going to alter this equation dramatically. I'm saying instead of getting plus 3 minus 1 plus 1, I'm a strict teacher. I walk in and I say for every question I remove a mark. Every question I remove a mark. That is, every plus 3 will become plus 2. Every minus 1 will become minus 2. Every 1 will become 0. Unattempted questions, you get 0 marks. I'm removing a x, y, z totally from it. From this, we subtract x plus y plus z. Algebraically, what are we doing? We're subtracting this equation from this. 2x minus 2y equals 22. Conceptually, what are we doing? We're removing 75 marks. Each question we are cutting 1 mark. Or the total mark is not 97, it's only 22. You get 2x minus 2y equals 22. 2x minus 2y is 22. Or x minus y is 11. Right? We want the maximum possible value of x. And x plus y can be a maximum of 37. This is a maximum value. X plus y maximum is 37. How do I know that? Because this total z is more than x and y put together. So if x plus y is higher, that's when x can be higher. Add these two. So the maximum value is 2x is 48, or x maximum is 24. We know x minus y is 11. That much we have figured out. We've got. We can figure out now that x plus y maximum is 37. Only if x plus y is higher, x plus y can go to, the higher x can be. Maximum it can go to is 37. 2x is 48, x is 24. X is 24, that gives y as 13. 24 correct answer, 13 incorrect answers, adding up to 37, 38 unattempted. That will give us answer. Or the maximum number of correct answers that Ryan could have given in the examination is 24. 24 into 3 is 72, plus 13, 24 into 3 is 72, plus how much is this? 13 into 1, 13 into minus 1, and then remaining 38 into plus 1 should add up to 97. 5 students, including Amit, appear for an examination with possible marks in which possible marks are integers between 0 and 50, both inclusive. Average marks for all the students is 38, and exactly 3 students got more than 32. If no student got the same marks and Amit got the least marks among the 5, then the difference between the highest and lowest possible marks of Amit is nice. So S1, S2, S3, S4, A. Amit is the least. Exactly 3 students got more than 32. These 3 have got more than 32. Nice. And Amit got the least mark. S4 should be less than or equal to 32. These two are more than 32. Exactly 3 got more than 32. This could be 32. That's the situation we have now. Average is 38. Nice. First we want to find Amit maximum and Amit minimum. Both of that we want to find. Let's think about Amit maximum. S4 maximum can be 32. I want to put S4 as 32. Amit maximum is 31. These three are all greater than 32, greater than 32, greater than 32. 32 plus 31 is 63. Total is 190. Why 190? 38 into 5. From this you subtract 63. 127. 127 broken into 3 parts. Adding up to 127, all more than 32, less than 50. Possible. I put as 40, 41, 46. It should happen. This is possible. So our Amit max is 31. Nice. That's the maximum possible. It cannot be more than 31. He cannot be 32. This is 32. This has to be 33. It will be more than 32. Only 3 have got more than 32. Amit, yes, maximum can be 31. Minimum. Amit has to be minimum. Everything else has to be maximum, as high as possible. So what do I put? I put this guy as 50. As 49. This guy as 48. And this guy as 32. Add everything up. 2 plus 8, 10, 19, 9, 1, 6 plus 4, 10, 14, 17, 179. Total is 190. These 4 fellows add up to 179. Amit will have 11. So I could have 50, 49, 48, 32, 11. That's a possibility. Or Amit minimum equal to 11. The difference between maximum and minimum is 20. Very nice question. Capture all the detail. Keep in mind that average is 38, so sum should be 190. 3 are more than 32. That means the fourth one is less than or equal to 32. It could still be equal to 32. Amit is the least. If Amit has to be maximum, then S4 has to be as high. The maximum value S4 can take is 32. Amit maximum can be 1 less than S4, 31. Easy. Amit has to be minimum. Other 4 have to be as high as possible. 50, 49, 48, 32 is the best scenario, which makes Amit as 11. 21 minus 11, 31 minus 11 is 20. The number of integer solutions of the equation x square minus 10 whole part x square minus 3x minus 10 equal to 1 is a very beautiful question. First of all, something power 0 is 1. 1 power anything is 1. So what do we now need to do? We have to solve for this going to 1 or this going to 0. Get those values, substitute in the other part, and then see if it is logical, whether it does make sense. And so what I'm going to do, I'm going to solve 2 different equations. I'm going to say x square minus 3x minus 10 equal to 0. Get the answers. I'm going to find x square minus 10 equal to 1 and get the answers. And then think about simplifying this. Nice. So x square minus 3x minus 10 is 0, or x minus 5 into x plus 2 equal to 0. X is 5 or x is minus 2. If it are 5 square minus 10 whole power 0, that will be 1. If it are minus 2 square is 4 minus 10 minus 6 power 0, that is 1. So 5 works, minus 2 works. Nice, brilliant. 1 power anything is 1. That is super interesting. So we'll say x square minus 10 is 1. X square is 11. X is plus or minus root 11. The 2 possible values, this could be root 11, in which case that will be some irrational thing. Do we need to worry about it? I don't need to worry about it at all, because in this case, we talk about integer solutions. X equal to plus root 11 minus root 11 simply doesn't work. If something per something is 1, either this base should be 1 or that number there should be 0. Put base equal to 1, solve. The exponent should be 0, solve, we are through. Have I completed everything? No, I have not. There's one more possibility here, which is minus 1 square is 1, minus 1 power 4 is 1, minus 1 power an even number is 1. So there is a possibility of that happening. in which case I'll have to verify that. So I'm going to solve for x square minus 10 equal to minus 1, or x square equal to plus 10 minus 1, which is 9. That means x is equal to plus or minus 3. I got this far, but I cannot be sure that this will work, because for plus 3 and minus 3, my exponent should be an integer. More than that, it should be an even number. If it's an even number, then I am happy. But minus 1 per 101 will be minus 1. Minus 1 per 94 will be plus 1. So to substitute x equal to plus 3 minus 3, I have to verify whether it turns out to be an even number. Let's do that. This is x minus 5 into x plus 2. I put 3 minus 5 into 3 plus 2, which is minus 2 into 5, which is minus 10. Yeah, that works. I put minus 3 minus 5 into minus 3 plus 2, minus 8 into minus 1 equal to 8. This also works. Both are even numbers, both work. Therefore, x could be 3 or minus 3. We already got that x could be 5 or minus 2. So we have 5, minus 2, 3, minus 3. For 3 and minus 3, this goes to minus 1. That's an even number. We are very happy. For 5 and minus 2, this goes to some number that goes to 0. We are happy. 4 different values are possible. Beautiful question. Mr. Pinto invest 1/5 of his capital at X% at 6%, 1 by 5 at 6%, 1/3 at 10%, 1/3 at 10%, and the remaining at 1%. Remaining, right? So 1 by 5 plus 1 by 3 is 3 plus 5, 8 by 15. So 7 by 15. Remaining is 7 by 15 at 10%. No, not 10%, 1%. Sorry about that. I will fix that. Each rate being simple interest per annum, then the minimum number of years required for the cumulative interest income from these investments to equal or exceed this capital. Nice. Find the weighted average interest rate. It's all simple interest. 1 by 3, 1 by 5 and 7 by 5. Find the weighted average rate, or 1 by 5 is 5 by 15. Sorry, 3 by 15, 5 by 15, 7 by 15. So 3 into 6% plus 5 into 10% plus 7 into 1% divided by 15. 3 into 6 is 18, 5 into 10 is 50, 18 plus 50 plus 7 divided by 15. 68 plus 7, 75 by 15, this is 5%. The weighted average of all of this is 5%. So it's like saying he's taken his whole capital and put it in for 5%. The cumulative interest income from these investments to equal or exceed his initial capital. Interest should be equal to capital. You're getting 5% per year, simple interest. 2 years you'll get 10%, 3 years you'll get 15%, 20 years you'll get 100%. 20 years exactly he'll have a capital, an interest equal to capital. So cumulative interest from these investments to equal or exceed it, equal in 20 years. 20 is our answer. Consider the arithmetic progression 3, 7, 11, 15, 19, etc. plus 4 plus 4 plus 4. And let a n denote the sum of the first n terms of this progression. Then the value of 1 by 25 summation times n equal to 1 to 25 times a n is. Very nice. We'll do the brute force method. So the progression is 3, 7, 11, 15. First term is, first term is 3, common difference is 4. Sum up to n terms is n by 2 times 2a plus n minus 1 into d. This is n by 2 times 2 into 3, 6 plus n minus 1 times 4. Which is 4n minus 4, n by 2 times 6 plus 4n minus 4. 4n, this becomes 4n plus 2. This is n by 2 times 4n plus 2, or n times 2n plus 1. When n is 1, this is 1 into 3, 3, yeah. When n is 2, this is 2 into 5, 10, yeah, that works. Or an is n times 2n plus 1. We want to do sigma an and then do a 1 by 25 of it. 1 to 25 times, then divide by 25. So what do? I do summation an of 2n square plus n. 2 times sigma n square plus sigma n. 2 times n into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 by 2. Into this I substitute n equal to 25 and then divide by 25. We have a 1 by 25 outside. Or this is just n. I'm going to do for 1 to 25. Or put n equal to 25 and do a 1 by 25. N is 25. So cancel 125 completely. 2 by 6 is 1 by 3. N plus 1 into 2n plus 1 by 3 plus n plus 1 by 2. Where n is 25, 26 into 51 by 3 plus 26 by 2. This is 13. 26 into 17, 17 6 are 102, 210, 17 into 2 is 34 plus 10, 44, 442 plus 13, which is 455. Just pure unadulterated raw brute force. I tried to do it by more elegant method. I didn't go anywhere. I didn't get anywhere. I thought I'll do 3 plus 7, 3 plus 7 plus 11, 3 plus 7 plus 11 plus 15, all of that. So I do sigma 1 to 25 an. My first term gets added 25 times, second term gets added 24 times, third term gets added 23 times, all the way to the 25th term, which just gets added one time. And then I divide by 25. I didn't go anywhere. I didn't get anywhere with that. I decided, look, I'm not doing any cute thing. Brute force it, get to the answer. F of x be a quadratic polynomial in x such that f of x is greater than or equal to 0 for all real numbers. And so, nice. So f of x is greater than or equal to 0 for all real numbers. Like something like this, a curve like this. Right? So a curve that is completely above the x-axis, where it doesn't touch it. Because if f of x were 0 for some number, it will touch the x-axis. It will cut the x-axis. Wherever it goes to 0, it will cut the x-axis at those points. This is a graph like this. F of 2 equal to 0. Okay, f of 2 is equal to 0 and f of 4 is equal to 6. So f of 2 is equal to 0. What does it mean? I remove this. And I say, okay, this is not flying above the x-axis. It is touching the x-axis. F of at 2, it goes to 0. Okay? Or this has two roots, both at 2. This cuts off at 2. Or this is of the form x minus 2 whole square. It's a curve x minus 2 whole square. Now, f of 4 is 6. I thought it was x minus 2 whole square. I was very happy. I got f of 4 equal to 6. F of 4 is 2 minus 2 whole square, which is 4. It's not 6. And I said, look, it's not x minus 2 whole square. This is a curve which is k times x minus 2 whole square. It cuts at 2. It touches at 2. So there's two real roots, both at 2. This is from x minus 2 into x minus 2 whole square. Not just x minus 2 whole square, k times x minus 2 whole square. Right? That is this curve. Nice. F of 4 is 6. So k times 4 minus 2 whole square is 6. K times 4 is 6. K is 6 by 4, which is 3 by 2. Or our curve f of x is 3 by 2 times x minus 2 whole square. This will have f of x greater than or equal to 0 for all real values. This will have f of 2 equal to 0. This will have f of 4 equal to 6. Everything gets satisfied. F of minus 2 is equal to, so it's 3 by 2 times minus 2 the whole square minus 4 square, 3 by 2 into 16, 3 into 8, 24. The understanding of what that means, that f of x is greater than 0, that means flying above the x-axis. F of x is greater than or equal to 0, it could be flying or touching. It does completely greater than or equal to 0, but with one point equal to 0. That means it has real and equal roots, both roots being 2. It is of the form x minus 2 whole square. What do I mean of the form x minus 2 whole square? K times x minus 2 whole square. I wrote this down as x minus 2 whole square and I was like, this doesn't work. Like, no, it is a multiple of x minus 2 whole square. The length of each side of an equilateral triangle ABC is 3 centimeters. ABC 3, 3, 3. Let D be a point on BC such that area of triangle ADC is half the area of triangle ABD. D is some point here. This area is half of this. The height is the same. Bases should be in the ratio 1:2, or BD is 2, DC is 1. Nice. The length of AD in centimeters is, we want to find AD. This angle is 60. We have two sides and the angle in between that. We can find this answer. How do we find this answer? We use the beautiful cosine rule. And so we know that AD square in that triangle is AC square plus DC square minus 2 times AC into DC into cos angle ACD. Direct plugging in of cosine rule, nothing else, but you've got to know cosine rule to have a crack at this. Or AD square equals AC square 3 square DC square 1 square minus 2 into 3 into 1 into cos 60, which is 1 by 2. Just 9 plus 1 minus 3. This is AD square, which is 9 plus 1, 10 minus 3, which is 7. Or AD is root 7. If you know cosine rule, this becomes super easy. If you don't know cosine rule, it's a complete nightmare. Take away from this, no cosine rule. Learn cosine rule. Two ships meet mid-ocean and then one ship goes south and another ship goes west. Both traveling at constant speeds. 2 hours later, they're 60 kilometers apart. This distance is 60 kilometers. If the speed of one of the ships is 6 kilometers per hour more than the other one, then the speed in kilometers per hour of the slower ship. Say slower ship is this one. Say it's at x. This is 2x. This is 2 times x plus 6. Speed of the slower ship, let it be x kilometers per hour. 2 hours it will travel 2x kilometers. The faster ships will be x plus 6 kilometers per hour. In 2 hours it will follow 2 times x plus 6. Now this is 2x. This is 2x plus 12. Difference is 12. Chances are this is a beautiful Pythagorean triplet. 60. I will think about 3, 4, 5. Or 5, 12, 13 or 7, 24, 25. This is 60, 60, 48, 36. The difference between these two is 12. That works. So this is 36, 48, 60. That's the Pythagorean triplet. So the faster ship has covered 48 kilometers. Slower ship has covered 36 kilometers. 36 kilometers in 2 hours. In 1 hour it travels 18 kilometers. Speed is 18 kilometers per hour. 18 kilometers per hour into 2 is 36. 24 kilometers per hour into 2 is 48. 36, 48, 60 is the right angle triangle Pythagorean triplet. We are through.